Introduction to Complex Numbers, Part 2. In this video, we'll be discussing about the general format of a complex number and the magnitude of a complex number. General format of a complex number. In the last video, we saw that we assigned a variable I or j is equal to square root of minus 1. Now, the general format in which this can be expressed is, let's assign a variable for the entire complex number. Say z in this case. Z is equal to a plus or minus ib, where a and b are variables that can be any numbers. For example, we can have the complex number 2 plus 3i. Z is equal to, Z1 is equal to 2 plus 3i. Here, A is equal to 2, B is equal to 3. Let's take Z2 is equal to minus 5 plus 4i. A is equal to minus 5, B is equal to 4. Z3 is equal to 4i. In this case, A will be 0 and B will be plus 4. Z4 is equal to, let's say 0, let's just say 4. In this case, B is equal to 0, A is equal to plus 4. Now, in this general format, if you notice, the variable A doesn't have the complex number I multiplied with it. It is combined with either an addition or a subtraction symbol. But B, on the other hand, is multiplied with the complex number I. So generally, A is referred to as the real part of the complex number and B is referred to as the imaginary part of the complex number. Now, there is a short form to express the real part of a complex number. We can say that A is equal to capital RE, real part of the complex number Z. Similarly, B can be represented as the IM, imaginary part of the complex number Z. So basically, the general format in which you can write a complex number is Z is equal to real part of the complex number Z plus or minus the complex number I multiplied with the imaginary part of Z. So in each of these examples that we see, A is the real part and B is the imaginary part. Now that we have established the general format of a complex number, we'll move on to something called the magnitude of a complex number. Now, a complex number, let's take the general format. Z is equal to real part of Z plus or minus I into imaginary part of Z. Yes. This is the general format of a complex number. Now, magnitude. What is the meaning of the word magnitude? Let's say it means something like net value, the overall value as a single real number, so that we'll know what its magnitude is, what its quantity is. To find the magnitude is represented by the symbol modulus. Modulus is just two straight lines covering the contents in between. This means that we are finding the magnitude of the complex number. So in this case, magnitude of the complex number z will be equal to square root of real part of z square plus imaginary part of z square. To simplify this even more, let's take our initial format, a plus or minus ib. In this case, mod of z, or the magnitude of the complex number z, is equal to square root of a square plus b square. Let's take an example. Let's take the example complex number z1 is equal to 4 plus 2i. Now a here, or the real part of z1, is equal to 4. b, or the imaginary part of z1, is equal to plus 2. Now, to find the modulus of z, or the magnitude of the complex number z1, you have to find square root of real part square plus imaginary part square, which is 2 square, which is square root of 16 plus 4, which is equal to square root of 20. Now, if you want, you can further simplify it and write it as 2 root 5. This is the magnitude of the complex number. Now, note that the magnitude of a complex number is always not complex itself. If you notice, the final result was a real number. It's not a complex number. So always the outcome of the magnitude of a complex number is always a real number.